Hello class 7 students. How are you all? I hope you all are doing well. I am Priyanka Singh, your digital mentor. So, today I am here to start with the chapter number 5 of science. So, the name of the chapter 5 is acid, bases and salts. There are a large number of edible substances like lemon, salt, sugar, tamarind, curd, etc. which we use in our daily life. Do they have the same taste? Let us recall the tastes of few edible substances given in table. So students, are you able to see this table? So, serial number, substances, taste, sour, bitter, salty, sweet, any other. So, number 1 is lemon juice. And the taste of the lemon juice is sour. On number 2, there is orange juice. The taste of orange juice is sour and sweet. And on number 3, there is a curd. The taste of the curd is sour. Number 4, grapes. Taste sour and sweet. 5, sugar. Taste sweet. Number 6, common salt. Taste salty. Number 7, amla. Taste bitter. Number 8, unripe mango. Taste sour. Number 9, baking soda. Taste bitter. Number 10, tamarind. That is imli. And the taste of tamarind is sour. Number 11, vinegar. Taste sour. Number 12, glucose. Taste sweet. In the table, we find these substances taste sour, some taste bitter, some taste sweet and some taste salty. Acids. Substances like lemon, vinegar, curd, etc. taste sour. Do you know why? It is because these substances contain chemicals called acids, which give them their sour taste. The term acid comes from the Latin word acer, which means sour. All acids have a sour taste. Acids are of two types: natural acids and mineral acids. Natural acids, they are organic acids. The acids which are found in plants and animals are called natural acids or organic acids. Natural acid and their sources. The table given below gives the name of natural or organic acids and their sources. So children, are you able to see the table? So serial number, name of natural or organic acid. Sources. Number 1, citric acid. Source, citrus fruits such as oranges, lemon, etc. Number 2, lactic acid. Source, curd. Number 3, ascorbic acid. Source, amla, citrus fruits. Number 4, tartaric acid. Sources, tamarind, grapes, unripe mangoes, etc. Number 5, acetic acid. Source, vinegar. Number 6, oxalic acid. Source, spinach, tomatoes, guava, etc. Number 7, malic acid. Source, apples. Number 8, amino acid. Source, proteins. Number 9, tannic acid. Source, tea. Number 10, glycolic acid. Source, sugarcane juice. The natural or organic acids are weak acids. The dilute solutions of weak acid, that is, natural acids mixed with water to dilute them, are quite safe to consume. Many food like pickle and tomato ketchup contain acetic acid in the form of vinegar. Vinegar preserves fruits and vegetables. Tartaric acid is mixed with baking powder used in making cakes and biscuits. Mineral acids. The acids prepared from the minerals of the earth are called mineral acids. They are man-made acids and are also known as laboratory acids because they are used in the science laboratory to perform experiments. The most common mineral acids are number 1, sulfuric acid, number 2, nitric acid, number 3, hydrochloric acid. Mineral acids are very dangerous. They are highly corrosive in nature. These acids can cause severe burns on the skin. These acids should be handled with great care. They should never be handled with bare hands or tasted. Concentrated and dilute acids. All acids are solution of acidic gases in water. A solution containing the maximum amount of the acidic gas is called concentrated acid. A solution containing lesser amount of the acidic gas, that is, larger amount of water, is called dilute acid. Thus, acid solutions of different concentration can be prepared by changing the relative amount of the gas and water. In practice, dilute acid is prepared by slowly adding the required amount of concentrated acid into the calculated amount of water with constant stirring. Uses of acids. Sulfuric acid. Sulfuric acid, H2SO4, known as the king of chemicals, is used in manufacturing of detergents, paints, fertilizers and many salts. Sulfuric acid is used in automobile batteries and fire extinguisher. It is used in petroleum industry for refining. It is used in the manufacturing of fertilizers such as superphosphate and ammonium sulfate. Nitric acid. It is used in the manufacturing of fertilizers such as ammonium nitrate. It is used to preparing aqua regia. It is used in the refining of gold and silver. It is used to make explosives such as nitroglycerin and trinitrotoluene TNT. Hydrochloric acid. It is used to make dyes, glue and medicines. It is used to prepare glucose from starch. It is used in the purification of common salt. It is used to prepare aqua regia, a mixture of 3 parts of HCl and 1 part of HNO3O, which is used for dissolving many metals. Base. Taste a pinch of baking soda. It has bitter taste. Make a solution of baking soda in water. Put a teaspoon of this solution on your hand and rub it with your fingers. It has a soapy feel. Substances which are bitter to taste and feel soapy on touch are called bases. Materials containing a base are called base-in substances. Bases are substances that produce hydroxyl ion OH when dissolved in water. NaOH, that is sodium hydroxide. NaOH, sodium hydroxide, is a mixture of Na, that is sodium ion, plus OH negative, that is hydroxyl ion. Greater the amount of OH negative ions produced, the stronger is the base. Bases that are soluble in water are called alkalis. Example, sodium hydroxide, potassium hydroxide, magnesium hydroxide. All hydroxide compounds are bases, but only water-soluble bases are alkalis. So, we can say is that all alkalis are bases, but all bases are not alkalis. So, some common bases and alkalis. So, students, are you able to see this table? In this table, there are some common bases and alkalis and their chemical formulas. So, we are starting with the base and their chemical formula. The first one is zinc hydroxide. Chemical formula ZnOH2. Magnesium hydroxide. Chemical name MgOH2. Copper hydroxide. Chemical name CuOH2. Aluminium hydroxide, AlOH3. Now, we are starting with the alkali and their chemical formulas. So, the first one is sodium hydroxide, chemical name NaOH. Potassium hydroxide, chemical KOH. Ammonium hydroxide, chemical name NH4OH. Calcium hydroxide, chemical name CaOH2. Uses of bases or alkalis. The uses of some typical bases are described below. Sodium hydroxide, caustic soda, NaOH. In the manufacture of soap, sodium hydrochloride and other industry chemicals. In the manufacture of industrial cleaners, which are used to remove oil and their impurities from metals. in preparation of artificial milk, in preparation of salt, in manufacturing of rayon, cellophane, textiles and paper. Calcium hydroxide, slaked lime, CaOH2, in whitewash, in preparation of lime water, in building construction, in manufacture of bleaching powder, in treatment of water and wastewater. Ammonium hydroxide, NH4OH. It is used to manufacture fertilizers. It is used to manufacture nylon, plastics, dyes, rubbers, etc. It is used in refrigerator processes. Aluminium hydroxide, AlOH3, for preparing antacids in textile industry. Magnesium hydroxide, that is MgOH2, used in making antacid formulations. Indicators. We know that acids are sour while bases are bitter in taste. But we cannot taste all substances to find whether they are acidic or bases in nature. It is because some substances may be harmful to us. Now the question arises, if we cannot taste every substance, how we do find its nature? We use indicators. Indicators are special types of substances which are used to test whether a substance is acidic or basic in nature. How do the indicators work? The indicators change their color when added to a solution containing an acidic or a basic solution. Turmeric, litmus, China rose petals, etc. are some of the naturally occurring indicators. Phenolphthalein, methyl orange, etc. are some of the man-made indicators. Natural indicators. First, litmus. Litmus is a natural indicator made from the extract of lichens. There are two types of litmus. A. Red litmus paper. When red litmus paper is treated with base, it changes into blue color. B. Blue litmus paper. When blue litmus paper is treated with acid, it turns into pink or red. The second one is turmeric. Turmeric is used as spice in all homes. Turmeric acts as a very good indicator for acids and bases. Steps to make turmeric paper. Mix small amount of turmeric in a little water to make a paste. Now apply this paste on a blotting filter paper and allow it to dry. Cut thin strips of this yellow paper. Now use this to differentiate between acids and bases. When your mother washes utensils in kitchen having turmeric on them, the color immediately changes red when soap detergent is applied. This is because bases give a red color with turmeric as indicator. Third, China rose. China rose or hibiscus is a flower whose petals can be used as a natural indicator. China rose or hibiscus indicator turns the color of acidic solution of dark pink and that of basic solution to green. Phenolphthalein, man-made indicator. Phenolphthalein is an organic dye. Phenolphthalein indicator is prepared by dissolving the phenolphthalein dye in alcohol. Its solution is colorless. Basic solution or bases like baking soda solution, shampoo solution, etc. change colorless phenolphthalein solution into deep pink color. Colorless phenolphthalein solution remains colorless when acids or neutral solution are added. Now children, are you able to see this table? This table is giving us the differentiation between the acids and bases. So come and see what is the difference between acids and bases. Number 1. Acids are sour in taste. Bases are bitter in taste. Number 2. Acids give corrosive touch. Bases give soapy touch. Number 3. Acid turn blue litmus to red. Bases turn red litmus to blue. Number 4. Acid have no effect on the color of turmeric paper. Bases turn turmeric paper red. Number 5. Acid turn China rose indicator to magenta. Bases turn China rose indicator to green. Number 6. Acid turn methyl orange to red. Bases turn methyl orange to yellow. Number 7. Acid turn purple color of red cabbage to red. Bases turn purple color of red cabbage to green. Number 8. Acid do not change the color of phenolphthalein. Bases turn colorless phenolphthalein to pink. Neutralization reaction. A chemical reaction between an acid and a base is called neutralization reaction. Salt and water are formed in this process, which the evolution of heat energy. Acid plus base. Salt plus water plus heat. From the observation that the test tube has become warm, we conclude that heat is evolved during a neutralization reaction. Thus, the neutralization reaction between an acid and a base is an exothermic reaction. The reaction between an acid and base or an alkali to form a salt and water is called neutralization reaction. The salt formed may give acidic, basic or neutral solution. For example, sodium hydroxide plus hydrochloric acid gives sodium chloride plus water plus heat. Sodium hydroxide plus sulfuric acid gives sodium sulfate plus water plus heat. During the reaction between lime water and dilute sulfuric acid, heat is evolved. Therefore, reaction mixture becomes hot. Lime water plus sulfuric acid gives calcium sulfate plus water plus heat. Neutralization in everyday life. In treating indigestion, hydrochloric acid is present in our stomach. This helps in creating right conditions to digest our food. It also kills the germs that might make us ill. If a person overeats, too much acid is produced in the stomach. This causes indigestion. To neutralize the excess acid formed in the stomach, antacids like milk of magnesia is taken. Milk of magnesia contains a base called magnesium hydroxide. In treating stings of ant and bee, the sting of an ant or a bee is acidic as it contains formic acid. The pain caused due to an ant sting or a bee sting can be neutralized by using bases like sodium bicarbonate solution NaHCO3, also called baking soda, or calamine lotion. In the treatment of tooth decay, tooth decay is caused due to an acid that is produced by bacteria present in our mouth. If we do not clean our teeth properly, the bits of food remain between our teeth. Certain bacteria live on these bits of food and produce acid. This acid is the cause of tooth decay. Toothpaste are basic in nature and neutralize this acid and thus help in preventing tooth decay. That is why dentists advise us to brush the teeth at least twice a day. In the treatment of soil, plants grow well in neutral soil. Plants do not grow well when the soil is either too acidic or too basic. This in turn reduces the fertility of the soil. Excessive use of chemical fertilizer make the soil acidic. When the soil is too acidic, it is treated with bases such as quicklime, calcium oxide, slaked lime, calcium hydroxide. When the soil is too basic, then decaying organic matter called manure or compost is added to it. These manures release acids which neutralize the basic nature of the soil. In the treatment of industrial waste, the industrial waste is either too acidic or too basic. Too much of acid or base must be neutralized before discharging this waste into nullans or rivers. Too acidic industrial waste can be treated with quicklime or slaked lime to neutralize the excess acid. Too basic industrial waste can be treated with either acid or acidic waste discharge from some other industry. So, it's time for Reader's Digest. Acids are of two types, natural and mineral. The acids prepared from the minerals of the earth are called mineral acids. A solution containing the maximum amount of the acidic gas is called concentrated acid. A solution containing lesser amount of the acidic gas is called dilute acid. Acids are sour while bases are bitter in taste. A chemical reaction between an acid and a base is called neutralization reaction. So students, it's time to take your leave. We'll meet in the next class. Bye.